One optional and advanced concentration inequality is Talagrand concentration inequality. Uh, Rather than the original form, I recommend to read the theorem 2.1.13 of topics in random matrix theory written by Terence Tao. The statement is as follows. Let K positive, constant, and let x1 to xn be independent complex variables. To be simple, xn through x1 through xn be independent random variables with the range, the absolute value of xi bounded by some constant capital K for all index I, and let function f be one Lipschitz convex function. So we have additional constraint. The function f should be convex, which is one main difference with the previous, the McDiarmid inequality. And also we additionally have one Lipschitz continuous property as well. So with these two additional assumptions on function f, we can have much more powerful concentration inequality for the function value fx. The probability of the absolute value fx minus median of fx greater than or equal to lambda k, the lambda times the range of k, which is less than or equal to some constants times exponential minus another constant c times lambda square, which means the deviation from the median value decrease with the speed of exponential minus some constant lambda square. Here lambda is here, right? So this is very nice and powerful result. Here constant c and this constant c is a very minor factor. Most of the case, we are really interested in the conversion speed with respect to this lambda. And the constant here, especially this constant, you can move this constant inside the exponential with ln large c, capital C, and this value easily negligible as lambda go to infinity. When with very large lambda value, we can simply ignore ln c because ln c will be much smaller than the lambda square. Most of case in most of analysis of machine learning algorithm, we usually interested in the tail bound. Basically, we collect a lot of data point, millions or billions data point nowadays, and we really interested in the tail bound of the concentration inequality for very large observations or a very large deviation. And in that case, this constant c and small c are not important, and exponential minus some constant times lambda square is super powerful. Let's compare the Talagrand inequality with McDiarmid inequality. Both inequalities for some concentration inequality for some function value. Of course, McDiarmid is more powerful in terms of the constraint. Here, we do not assume anything on the function f. We do not assume Lipschitz continuity. We do not assume convexity for this concentration inequality. But when you look at this concentration inequality, you can easily notice that there is a denominator which increase linearly to the number of data point. Both concentration inequality have exponential form with minus t squared times some constant, but McDiarmid inequality decrease these constants with speed of 1 over n, right? But in Talagrand inequality, there is constant c which does not depend on the number of data point n. In that sense, Talagrand inequality more powerful, but we need one Lipschitz continuity condition and convex condition. Anyway, with these two conditions, we have very nice concentration inequality for both median and expectation, right? And this Talagrand inequality can be can be applied to many applications, especially when we have some matrix, random matrix A with 0 or 1 Bernoulli independent random variable. So in this book, basically, in this book, Terence Tao showed the spectral norm of this random matrix using Talagrand inequality because this spectral norm is convex function and Lipschitz continuous function. So using this Talagrand inequality, we can easily bounding the spectral norm of the random matrix. Okay, and also Talagrand inequality applied to many other interesting applications. So, so I want to introduce this very nice result, which is in Topics in Random Matrix Theory book by Terence Tao. But the proof is somewhat complicated, out of scope of this class. But if you are really, interested in to understand how to obtain this Talagrand inequality, I recommend to read the proof in this textbook. And if you have any question on the proof, feel free to post your question to our, Discord channel. Then I will give you some, answers and more detailed explanation if you want.